Welcome to this module. In this module, we'll dive into how we can actually transform HTML elements with the help of CSS. To be precise, we'll dive into how we can rotate, move, skew, or scale elements, and also how we can apply 3D transformations. So not just use 2 dimensions, but actually create a 3D effect, all with the help of CSS only. So let's dive into that. Now, to dive into CSS transformations, I'm back in our project. And now I want to transform this badge, this recommended badge we have here. We can rotate it and so on, and that is exactly what we'll start with. So back in our code, let's go into the packages folder, and there in the packages CSS file. And there we have this package badge class, or this class selector. Now, right now, the badge is positioned with position absolute, and top right 0, it has a margin of 1.2 rem. First of all, let's change that margin to 0 so that we have no margin on this element anymore. It now sits directly in the top right corner. Now, this is no transformation. Transformations are applied with a special property, the transform property. Now, we got a couple of key transformations, and that are moving the element, which we of course also can do with the help of top right, and for non-absolute elements, we also can move an element with the margin, for example. But this actually is hardware accelerated, and it keeps the element in the document flow. Well, not for this element because it's position absolute, but for a normal element it would. So moving the element with transformations is always a good idea if you really just want to move it visually. I want to start with a different transformation though, not with moving the element, but with rotating. And for that, let's use rotate set. I'll dive into the other options later in this module when we dive into 3D transformations. So here we enter a value in degrees, like 45 degrees, for example. If we enter this and we save that file, let's reload that page. Now we can see that our badge indeed is rotated by 45 degrees. Important, it rotates around the center of the element. You can change that though. You can change it with the help of the transform origin property. That's the second important property when it comes to normal 2D transformations. By default, this is set to center, but you can also set it to a value like left or left top. And if you would set it to left top, for example, watch this badge if I reload. Now it actually seems like it just moved down, but what actually happened is this top left corner, it stayed in its place. This is the place where the corner also was before we rotated it, because now it's rotating around that corner. So clockwise around this corner with positive degrees. If we enter negative degrees, it goes in the other direction. So this is what's happening now. It's rotating around this top left corner. You can also enter a value with pixels or rem to simply move the origin into the element. 0, 0 would be the same as top left, by the way, but you can also enter something like 1 rem to move 1 rem to the right and 1 rem down from the top left corner, or a percentage value. 50%, 50% would be equal to center, which is the default and therefore doesn't need to be set. But of course, you can also specify something like 25%, 50% to move it in 25% and down 50%. Then the origin would be somewhere where the C is probably. Now, that is what you can do. I'll stick to center here, and you don't need to specify transform origin in this case because that's the default. But for the reference, I'll add it here. Now, with this added, if we reload this, now we're back to the original view, where it's just rotated around the center of the box. Rotating, of course, is great, but it's in the wrong position. Let's see how we can fix this in the next lecture. In the last lecture, we rotated our element. We did this with rotate set, and transform origin helps us to define around which, point we want to rotate. Now we also want to move the element. And of course, we can do this with top and right. It's an absolute element. If we set top to, let's say, 1 rem here, we move it down by 1 rem. Therefore, it went down a little bit. Now, nothing wrong with using top and right. However, if the element wasn't positioned absolute, but instead statically, like a normal element, we couldn't use that. We could then use the margin to kind of move it in a hacky way, or set the position to relative to use top and right again. But there actually is a better way if you really just want to move it for some visual effects. And that is the translate property, or translate function to be precise, on the transform property. There you also get a couple of different values, and we'll focus on x and y for now. Translate z will become important for 3D transformations. And translate x allows you to move the element on the x-axis. Here you can enter rem, pixel, m, or percentages, so any normal units, and it will move the element to the right by the value you enter here. So if I enter 1 rem here, if I now reload, the element moves to the right a little bit. This becomes even clearer if I enter a higher value, like 10 rem here. If we enter 10 rem into translate x, now it's moved quite a bit to the right. It also moved down a bit, and that's happening because we rotated the element, so it's moving diagonally. You have to think of translate x as working on an x-axis which goes through the center of this box. So right now the x-axis isn't a normal horizontal line, it's a diagonal from the top left to the bottom right, so to say. If we remove the rotation, we would have a horizontal x-axis again. So this is important to keep in mind for understanding how translate x works if you also apply a rotation. Now, I don't want to move it by 10 rem anyways. I want to move it by 1, and I also want to move it on the y-axis maybe. So let's add translate y here, also 1 rem, and let's see where we end up then. If we enter this, it looks like that. Now, one thing I want to change before I continue moving it around, I want to increase the width of that element. I want to increase the width so that we can center the text and got some excess space to the left and to the right, which we can actually cut off once it's positioned correctly and once that extra space goes beyond the boundaries of that package box. The reason for this is that once we cut it off, it'll look like a really nice badge on this box. So for this, not related to transformations but useful here, I'll set a width of 12 rem and add text align center to that badge. With that in place, if I save and reload this, now this is our badge. And now we can try to position it in the way we want to position it. So for that, I'll go back to translate x and translate y. And let's actually try a negative value for translate y and 2 rem for translate x. Now this is getting closer to where I want it. Now maybe we need 3 rem for translate x to move it a bit further down to the right. This is looking almost perfect. 3.5 should do the trick, I believe. And now with that, we want to cut it off, which we can do non-transformation related by simply going to our package element, so to the package selector, and by adding overflow hidden there. This will make sure that any elements that go beyond the boundaries of the package box will be cropped. So now if we reload, we got this really nice badge sitting in the top right corner. And that is mainly achieved with transformations, so with rotating the element and with moving it. And again, why are we moving it with translate instead of top and right? You could use top and right. Translate x and y also get hardware acceleration though, and therefore are a good tool if you just want to visually reposition the element. So it's in general a good tool for that final fine-tuning to fit the element into the position you want to fit it to, especially when you're also working with other transformations like rotate. So with that, we got our badge finished and we learned about the basic transformations with rotate and translate x and y. Important to keep in mind, translate x and y, the axis changes when we rotate the element. The axis always goes through the center of that badge, at least if transform origin is set to center. With that out of the way, let's dive into 2 other transform functions we can use in the next lecture. We had a look at rotate and translate thus far to rotate or move the element. We also got 2 other ways of transforming an element. For that, let's go to the customers page. There, we got our nice customer images, and I want to transform these images too. For that, I'll go into my customers file, and in this customers CSS file, I want to transform the image container, which should transform the image together with itself. So here, to the testimonial image container, I'll also add the transform property. Now we saw that we can use the rotate and translate functions, but now I actually want to skew it. So let's use the skew function for that. The skew function also allows you to skew an element on the x or y axis. But here, if you just use the skew function like this, and you only enter one value, you're effectively also just skewing on the x-axis. So it's the same as skew x. Now, what does this mean to begin with? Let's start by entering both and see how it affects the container. Let's just start with skew x and save that and reload. And now you see that our image is skewed to the left. So it's like someone pulled our corners and pulled them to the left. This is the case for the image container and the image itself. If we now also specify skew y, let's say also 20 degrees here, and please note you enter degrees here as a value, not pixel or something like that. It's degrees. And now you reload. Now it's also skewed to on the y-axis. This becomes even clearer if I temporarily remove skew x here. Now you can see what happened. It's as someone pulled the corners up a bit. So the top left corner got pulled up a bit and the bottom left corner got pulled up a bit. So for skew x, someone pulled it to the left, so to say. For skew y, someone pulls it up. And if you enter negative values, it would be pulled to the right or pulled down. And please note, only one corner gets pulled, so to say, so the element transforms itself into a diamond form, into a rhombus. Now, I don't want to use skew y here. I want to use skew x. And we can also use just skew here. If we only enter one value, that'll be the x value. We could enter a y value here too, but I just want to have this, well, horizontal skewness. So now this is effectively the effect I want to have. However, the image looks really strange if it's skewed like this. It would be great if the container gets skewed, but the image actually stays the way it is. Now, to do that, we can go to the testimonial image selector, which targets the image itself. And there we can also enter transform and enter skew minus 20 degree. So with that, we're basically offsetting the skewness of the container. If we do that and we reload, now we can see the image does not get skewed, or basically it does get skewed, but we skew it in the opposite direction, and hence we reset the skewness applied by the container. But of course, this is not the final look we want to have. To get that final look, we need to do at least two more things. First of all, not related to the transformation, but often used along with it, let's use overflow hidden again on the testimonial image container. This is applied to ensure that the parts where the image goes outside of the container now are cropped. So if I reload, it looks better, but we have this white space in the bottom right corner. And for the bottom image, we got a white space on both corners actually. Well, it's the same for the top image, I guess. So what we can do here is we can increase the size of the image. So let's go back to our image transformation function, where we have skewness of minus 20 degree. And let's dive into the last transformation function we have. We saw rotate, translate, and skew. Now let's have a look at scale. Scale again allows you to scale the image on 3 axes. We'll dive into Z in the 3D transformations part. X allows you to basically increase the width of the image, and Y allows you to increase the height. So here we enter a normal integer value, so something like 2. This means it is twice the normal size. So if we save that and we reload, now it's strongly distorted because we stretch it on the x-axis. This is what scale effectively does. It doesn't keep the aspect ratio. So therefore, we should also set scale y, and we can set both if we just enter scale. A scale with just one value scales it on both axes, so on the x and on the y-axis. So if we enter scale 2 like this, now this looks better. It's a bit too big though, so let's maybe just use 1.2 as a factor. 1, of course, would be the default, so we don't see an effect there. And we can also shrink it with 0.5 and so on. But let's use 1.2 here as a scaled-as factor. And now this looks almost good, just a tiny bit to go. So maybe 1.4 is what we're looking for. And now this looks good in my opinion. Now we can see that our images look good and they are now in their newly shaped diamond form. Now one other thing I want to do is I want to change the width of this container. I want to change it from the 100% we have here to just 60%, let's say. Now if we reload on mobile view, we, well, can see that new shape a bit nicer, a bit easier. It looks nicer now in my opinion. And with that, we applied our transformations to the images on the customers page too. And now with that, more importantly, we also learned about skew and scale. Time for a short summary of what we learned thus far. We learned about the transform property and that we can control the origin of the transformation with the transform origin property. We can define around which part of the box it should rotate itself, where the axis should go through, and so on. And we learned about the 4 key transform functions you have: rotate, translate, scale, and skew. Now, you saw that there are often skew x, skew y, and just skew functions. And the same for scale, translate, and rotate. Now, you can use these shorthands, of course. For rotate, if we remove the set, let's go back to the packages page, we actually see we get the same result as before. So rotate, just like that, by default rotates around the set axis. So this is convenient, since we most of the time want to rotate around this axis. Most of the time we want to have that 2D transformation. Translate, if we don't enter anything else, will allow us to enter 1 or 2 values. If we only enter 1, like this, you see, it doesn't look that bad, but it's now only translating on the x-axis. The second value is what we need to enter to translate on the y-axis. So here, if we also enter -1 rem, then we have the same as before. We translate on the x-axis and on the y-axis. So with this 2-argument syntax, we're back to the original result. Now regarding the other functions for customers here, for skew, we're already using that function where we just skew on the x-axis. The second value would then be the y-axis, as you learned. And for scale, well, there, if we enter 1 value, we actually scale on both x and y at the same time. If we want to scale either of the two, we can use scale x and scale y. This is how you can work with these transform functions, and that's really all. That's 2 transformations. It's always useful to use these if you wanna, well, change elements just as you saw it here. Translate is useful, also together with animations, but highly useful are things like rotate, skew, and scale. Now that we had a detailed look at 2D transformations, which to be honest are the transformations you'll probably use the most often, let's have a look at 3D transformations now. For this, attached to this video, you find a very simple prepared demo theory project where we just got a red box in a container with a black border. This is the markup code for it. Now, I want to transform this box in a 3-dimensional way. And for that, we still use the transform property. But now let's, for example, look into rotating this again, but now not around the z-axis, but actually around a different axis, because the axes will become important here. If we have a look at the 3 axes we have, we got x, y, and z. How can we then rotate elements around these? We can rotate an element around the x-axis with rotate x. And now the important part here is the axis will be in the center of this element, at least if transform origin is set to center, and it spins itself around this x-axis. So here, this will actually rotate the element towards or away from you, so to say. For y, it also rotates around the y-axis, so it spins around that y-axis. This is how you can think about that. And for z, it spins around the z-axis, but the z-axis kind of pierces the element, coming from the back and going through the middle of it. This is why this leads to a 2D transformation, even though you might think that for z it should be highly 3-dimensional, because that z-axis is that 3rd dimension. But if you keep in mind that that axis kind of pierces the element, and the element spins around that axis, then it makes way more sense. So rotate y and x are actually the 2 functions that we can use to create 3D rotations. For other functions, it's different, but for rotate, this is how it is. So let's use them. Back in our project, let's use rotate X, for example, on the box, and let's enter 30 degrees here. If we save that, let's reload our page. Now it looks like as if the box simply shrank. But what's actually happening here is it's becoming smaller because it's rotating towards you. Now this becomes even clearer if we enter a value, like animate some text into that box. Let's give that text a white color, font family sans serif, simply because it doesn't look as ugly. And let's align it in the center, at least horizontally. Now if we reload, we got animate here as a text. Now this becomes even clearer if we actually increase the rotation to, let's say, 80 degrees. Now this is almost invisible, and if we increase this to 90 degrees, it's totally invisible, simply because it's now right at the point where it's about to flip on that x-axis. So if we enter 100 degrees here, then it just flipped, which is the reason why animate is now at the bottom. It flipped around the axis now. This should prove that we're talking about a 3D transformation here. So now with that, we got a basic 3D transformation. Let's now also add rotate Y. And let's set this to 30 degrees, for example. Now we're also rotating around the Y-axis, which is the reason why if you reload, it looks like that. Now it's rotating towards you and around the Y-axis. Now this effect becomes clearer if we reset rotate X to 0 degrees for now, so that we got no X rotation. Now you can see it's again looking a bit squeezed here. If we increase rotate Y to 80 degrees, so right before it flips, now you see it's almost impossible to read because now it's almost rotated around the Y-axis. Now, right now we're always looking at this from the same distance. You can actually change this. We got our basic transformation set up. Let's now change the perspective from which we're looking at this. To change the perspective, we got a special function we can use on transform, perspective. There you enter a value in pixels or rem, like for example 100 pixels. If I enter 100 pixels and reload, now you see this looks as if we're sitting next to the element. And the reason for this is, the smaller the perspective is, so for example 1 pixel, the closer you are to the element. So for 1 pixel, we're right inside of the element, so to say. If we increase this to 1000 pixels, then we're really far away, but still closer to than we were before. So now we can actually see this 3D effect a bit better because it now goes outside of its surrounding box, and therefore it creates a 3D look. Instead of using the perspective function, you can also use the perspective property, by the way. You can set perspective here with the perspective property, and if you now reload, you don't see an effect, do you? The reason for this is that the perspective property actually has to be applied to the parent element. The advantage then is that you get the same perspective on all child elements. If you use perspective function, then each element where you apply it has its own perspective, even if they sit next to each other. This can lead to strange effects. So on the container, if we now reload, we're back to where we were. Now we're looking at all child elements of the container, of which we only have one, but if it were more, it would affect all. We're looking at all elements from the same perspective. Now you can also change the angle with perspective origin. Here, you by default have center, but you can also enter right, for example. If you enter right here and you reload, now it looks as if it rotated a bit more, but actually our perspective just moved to the right. So we're looking at this from a right angle now. And on the other hand, if we enter left here and we reload, now we're further on the left. You can also enter other values like 100 pixels here. This moves the perspective center to the right by 100 pixels. So if you now reload, you're further to the right. And if you enter an even bigger value, like 500 pixels here, and you then reload, now you're even more on the right. So this can be really useful to make sure that you look at the rotated element from the right perspective. And with that said, it now also becomes easier to see both rotate X and Y in action at the same time. If we now rotate X by 30 degrees, for example, and we keep our perspective on the container element, now we can reload, and now we actually see both transformations in effect again. It's rotating around the Y-axis and around the X-axis at the same time. We can now also introduce rotate Z to complete it and enter 30 degrees here. And now it's also rotating around that. Now it can be hard to see which rotation has which effect, but in the end you can always tweak and play around with these settings until you got your desired effect. Important to understand is simply that you can control both the rotation of the element on 3 axes as well as the perspective from which you're looking at this, both regarding the distance as well as the angle. Now that we got these basics set, let me remove all rotations but the Y rotation so that we're back to a easier to understand 3D transformation. Now we're just rotating around the Y-axis. And let me add a second box. I'll simply duplicate that box and make sure it also is inside of the container. And I'll give it a label of Animate2. The first one receives Animate1. And here I will name this box 2. And I'll change the selector or the class of the first one to box 1. The CSS file, I'll change that selector to box 1. Then I'll duplicate the code and enter box 2 here. Let's give that a blue background. Let's keep the width and height. And I'll remove transform on box 2 for now. Now if I save that and we reload the page, we actually see this result. Now the blue box is not inside of the container box, simply because we restrict the size of the container box and there already is one element with width 100%, height 100% in there. Let's quickly fix that by giving this a position of relative. So the container has this position and both boxes will now receive a position of absolute. Now if we reload, both are inside of that box. Now let's also transform the blue box here by re-adding a transform property to it. And let's give it a transform property of translate x1rem for now. If we now save that and we then reload, it simply moves to the right a bit, just as we saw it before. Now let's apply translate z then, to also see that in effect. We used translate y and x thus far. Translate z is now the 3D transformation for moving the element. Now it can be confusing, since for rotating we used y and x, but if you keep the axis setup in mind, it makes sense that translating the element, so moving the element, on the z-axis, which is the axis coming out of the screen, so to say, that moving the element on that axis actually is the one that creates a 3D effect. Now let's move it by, let's say, 10 rem there. Let's save that, and let's reload. And now you see it moved towards us. It became bigger because due to our perspective, moving an element towards us makes it bigger. On the other hand, if we enter minus 10 rem here, and we then reload, now it's moving back into that box, further away. Now if we enter a way bigger value like 100 rem, minus 100 rem, and we then reload, it's really small. And it looks like it's outside of the box here, but actually, even if I remove translate x, it stays inside of the box. You can't just think of that box as extending as a 3D space into, well, that 3D area behind it. So it's actually moved further into the box, so to say. And since we have a perspective coming from the right, we look at this from the right side. This should become clearer if I reset my perspective origin to center for now. If I then reload the page, now you can see it's still in the box, just moved further into the back. It doesn't actually go behind our red box, simply because the set index still applies when it comes to how these elements stack. They don't actually intersect. Now let me change that perspective back to 500 pixel again, and let me now show you something interesting in the next lecture. What happens if we also transform the container? Thus far, we transformed the elements in our container. Let's now transform the container itself. let's transform it by rotating it. By rotating it around the y-axis, let's say. Let's rotate it by 45 degrees. Let's save that. So I'm on the container now. Now if I reload, you see the elements moved a bit because the parent container also rotates. If I rotate the parent container by 90 degrees, so we shouldn't see the container, and I reload the page, everything is hidden. Now, of course, logically this doesn't make a lot of sense, because even if the container is rotated by 90 degrees, since we also rotate the red box and move the blue box a little bit to the back, we should definitely see these two elements still, because they actually have their own 3D space inside of the container. The default behavior, however, flattens this 3D space, and you can change this behavior with another property which you add to the container. It's called transform style. The default value is flat, which means the container rotates and the elements move with the container, but they're actually in a flat 3D space in there. So the overall container is seen as one flat object. However, you can change that value to preserve-3D. With this value, the 3D position of the child elements is preserved. So now if you reload, you can actually still see the red box. Now the blue box is something we can't see because since we only translate but don't rotate it, it has the same angle as the parent element, which right now is rotated by 90 degrees and therefore is perfectly invisible. If we change this to 95 again and we reload, then we can see the border of our container again. We don't see the blue box. The reason for this is that, keep in mind, the blue element is in front of the red element. And since we're flipping everything here, in front now actually means in the back. Yeah, it can be tricky to wrap your head around that. But the easiest way to get into this really is just to build a simple demo like this and play around with it to see how elements move around and change their look or how the visual effect changes. If we increase this to 130 degrees, we flip this element further, then we'll soon reach the point where we can see the blue box again. Of course, one way to see it right now would be to give the red box a set index of 1 so that it sits in front of the blue box. And with that, if we reload, and we also decrease the translate set value of the blue box to, let's say, -10, then we can see it. With a higher translate set value, we couldn't see it because that actually also moved it out of the screen. Because again, we're flipping this, so a negative translate set value now actually leads to this element moving towards us and out of the screen to the left, to be precise, and therefore a smaller distance moves it closer to the container, closer to the red box. And the red box is behind the blue box, even though it has a set index, because we're flipping everything, as you can see by the reversed text here. So 3D transformations can really mess with your head, but also allow you to create really powerful visual effects on your page. There's one last thing with flipping effects like this one, where we're effectively flipping a box. Right now, we see the back of the box like this. We can change that behavior by going to the element, for example, box 1, the red box, and adding back face visibility here. Now we can hide the back face with hidden. If we do that and we now reload, you see it's gone. It's gone because we're telling it, hey, if you're flipping and you are seeing your back, please don't show anything. We can also set back face visibility to visible. That's the alternative. Now that's the default also, so we don't need to set this. It's just something I want to bring to your attention. If you want to hide the back of an element whilst it's flipping, use back face visibility hidden. Now all these properties do have a different level of browser support, so definitely check the last lecture of this module to find out if your favorite feature is supported in the browsers you need to support. So that's it. That was it for this module. You learned about the transform property. You learned that you can use translate to move the element around on the different axes. You learned about scale, rotate, and skew, and that these functions can all be applied as values on the transform property to change the look of your element just as you need it. You learned that 3D transformations are possible via the z-axis, or for rotate actually via the x and y axis due to the way elements rotate around axes, and that you can use transform origin and transform style to change how your elements actually transform. You also learned about perspective, very useful for 3D animations, and that this allows you to define the perspective, or the distance from the object of the viewer. You also learned about perspective origin, which allows you to manipulate the origin of the viewer, which means the angle at which you're looking at a transformation. And these are the key things you need to know about the transform property, which can help you build really powerful visual effects.